Okay, I think we have enough folks joining. I'll get started and then uh, good morning, good afternoon, good evening, depends on, I'm assuming most of the folks joining from US, but I want to warm welcome everybody into Rocky Mountain User Group Training Day 2023. My name is Shailesh Rangani and I'm Director and Practice Lead for PostgreSQL at DataWhale. I have been associated with database technology for over 18 years. Most of the time I have spent is working on Oracle, DB2LUW, PostgreSQL, and MongoDB. So yeah, I'm glad to be here with you today. Uh, if you have any question during presentation, feel free to use Q&A chat to type those, and then I'll try answering. We'll try to spare last few minutes to answer those. If not, I'll also try answering in between as it's possible. Uh, Idea behind this session is to give you some quick start if you are learning or planning to learn PostgreSQL, and if you have a Oracle database as a background. So before we get started, let's quickly go through some introduction about myself and DataWhale, for which I work for. So um, my name is Shailesh Rangani, as I mentioned. I lead a Postgres practice at DataWhale. I've spent a lot of time learning various cloud technology and database technology. I have been doing anything related to database, could be design, deployment, administration. That's what I've been doing. A little bit about DataWhale. So we are specialized in database, data management, and application service. We are in industry for more than 16 years, mainly focusing on cloud platforms like AWS, Oracle, Azure. We also have our own tools called, and let me make a pointer here, tool called Service Boost and Tech Boost. So these are the tools which we use for improving efficiency of our team as well as improving customer experience. In our organization, we are 1,000 plus employee, staff 24/7, mainly focusing on professional services and uh, uh, managed services. Uh, we are across 5 different countries, resolving over 2 million incidents per year. So that's a little bit about my company or organization. Uh, Please, I've pasted this link in our chat, and let me do it one more time. Please fill this survey. Uh, this has the opportunity to. This will give you opportunity to win a top golf gift card. I'm sure a lot of you are interested in playing golf. So I'll probably give a few seconds here, so you have opportunity to, and then let's get started. So without further delay, let's get started. Why should you learn Postgres? I'm assuming that most of the folks sitting there are Oracle DBA or has some kind of Oracle background, right? The reason you should learn Postgres DBA because it's one of the most advanced open source. If you probably would have already observed the cloud giants like AWS, Azure, Microsoft Azure, or Google, they're also promoting or taking open source and building their own flavor of Postgres. Like AWS has Aurora PostgreSQL. Microsoft has Cosmos DB, which is a distributed PostgreSQL. Google Plus has Alloy DB, which got released last December timeframe, right? So in our today's agenda, we want what we're going to focus is we're going to learn PostgreSQL architecture, like logical and physical, some terminology comparison, how to install PostgreSQL, how to connect to PostgreSQL using various options, what are the backup recovery options, what are the high availability option, and we will learn all of these using the existing Oracle terminology. Okay, the idea is to quickly get familiarized through all of this terminology, features, and functions. One quick note is if you see any kind of comment on a red bubble or square or cloud, that's more related to Oracle. If you see something similar in a blue background, that would be related to PostgreSQL. So let's start with comparing Oracle with Postgres. So Postgres is just like Oracle. It's a relational database. The difference is it is maintained by a community or Postgres global development group, unlike Oracle. Like Oracle is produced and marketed by Oracle Corporation. Um, you know, so that's the key difference. One is a commercial product, one is an open source product. Oracle came or got released way before Postgres. So Postgres first came as a product for everybody to use in 1996, even though the first version got released in 1989, but 1996 onwards, it became open source and everybody started using that. Okay. Version perspective, version 20C is current in Oracle. I understand that 23C is supposed to get released this year. Postgres version 15 is the latest version. Okay. How version release works in a PostgreSQL is like every October, November timeframe, the newer version gets released. Like this year, version 16. So when I say this year, 2023, version 16 is expected to get released. Okay. Also, in the same time frame, one of the older version gets deprecated, like version 10 got deprecated in October, November 2022 timeframe, and version 11 is gonna get deprecated in October, November 2023 timeframe. Okay, so in short, every year Postgres community group release a one version every year. So this year the planned release is version 16. Okay. The license is open source in Postgres, unlike Oracle. So you can just download, start building your own product, or start using for your organization. There's no audit, no license fee, no nothing. Unlike Oracle. In Oracle, you have to buy license. Depends on whether your universal agreement or based on CPU or based on uh, uh, user usage. Depends on what's your agreement with that. Right? The implementation language, the Postgres was written into C, C++. Postgres was written into C while the Oracle is under C, C++. You can install PostgreSQL just like Oracle in various Unix platform as well as on Windows. But I have also seen on Oracle side that there are a few installation which works pretty specific to mainframe or ZOS. Uh, Postgres does follow ACID compliance just like Oracle. So when I say ACID, it's more like atomicity, consistency, isolation, and durability, right? These are the standard set of properties which guarantees that database transactions are processed reliably. Postgres does not have an in-memory capability just like Oracle, but there are efforts in progress for that. For server-side scripting, like in Oracle, you do like function, store procedure, trigger, procedure, right? All of this. You can achieve something pretty similar using PL, PGSQL, and they look pretty same. Official website. So this is postgres.org. This is where you find all the documentation, the information about various release, features, functionality, all of those. So let's quickly compare the architecture. Okay, and we're going to start with like logical architecture and then jump into a physical architecture. Again, I want to remind, if you have any question, please feel free to use this chat. I'll try to answer in between. If not, we'll try to answer at the end of the session. Okay, so if I start with Oracle instance is nothing but it's a memory plus background process, right? I have taken some of the sample background process here. I know, Oracle is pretty vast, so this is like very, very simple architecture just for a comparison purpose. But if I go in really complex, it could get really complex. So if I want to compare that with PostgreSQL, right? Postgres also has something similar. It's a Postgres instance, which is a memory plus background process. So let's start comparing some of the background process. Okay. Postgres has a database writer process, which writes the data from a shared buffer to disk, just like how Oracle would write from DBC to disk. Then it has a redo log or log writer buffer, where the redo log buffer gets written into a disk or redo file. Right? Similar way in Postgres, we call it val file, write ahead logging. Okay, where it writes the data from val buffer to val file. Okay, same concept what we do in a redo log. It has a checkpoint. So in Oracle, there are various scenarios where checkpoint occurs. The database comes to a consistent stage. Postgres has something similar feature where every 5-minute checkpoint happens and the data gets written from, flushed from disk to, memory to disk. It has an archiver process just like Oracle, where all the redo log file gets archived and used for point in time recovery. If you are taking a full backup and if you want to like recover for a specific time frame, this is what the archiver file will be used. Okay. If I want to compare like some of the uh, memory features, Postgres has a shared buffer. This is where all the data manipulation happens, like insert, update, delete. This is where all the blocks comes from disk to buffer, just like how that would happen in DBC. Postgres is a val buffer, which is similar to redo log file. And of course, there are a lot more other, but I'm going to keep it at the very high level. Postgres also has some of the background process called auto vacuum logger and state collector. So what they do is auto vacuum, it cleans the dead tuple, and we'll go into further slides on what is the dead tuple is, why auto vacuum process is required. State collector, so any insert, update, deletes are happening inside the database. Postgres keeps track of that. Okay, what kind of IO operations are happening, what are the wait events are happening. All these gets tracked by the state collector process. So this is a little bit about a logical comparison. If I want to go to a physical comparison, Oracle has a various kind of physical file, right? Data file, control file, redo log file, parameter file, password, and archive log file. If I want to do a side-by-side comparison, um, this is how the Postgres has various physical files. So if I want to start with a control file, Postgres also has a pg underscore control file and commit log file. These are the file which keeps track of uh, what are the consistency or what are the checkpoints, okay, and how the database consistency is. Postgres does have a data file. The reason I wrote a asterisk here is actually Postgres doesn't have a data file, but it has a table space. So once you create a table space, and if you create any object inside table space, it creates an individual file for each object. Like in Oracle, I would create a table space, and then I'll create a data file, assign that single data file to table space, right? And like if I create like 10 or 15 objects, they all will go into a same physical data file. But in case of Postgres, if you create like 3 different tables, let's say department, employee, and let's say something else, they all will have their own data file sitting inside the same table space. If I want to compare val file, which is your redo log file, or which is our redo log file in Oracle, parameter file, which is very similar to init.ora. This is where we put all the database related parameters. It could be tuning, or it could be vacuum related, it could be memory related parameters. All those parameters goes here, just like how I would set up something in init.ora. Okay. Postgres does not have a password file, but it has something called PGHPA, or a host-based authentication file. Also, it has an archive log file, which we discussed a little bit earlier, that's the one which is used for a recovery perspective, right? If you are trying to do point in time recovery, this is what you would be using. Okay, so that's more about logical and physical comparison. Let's jump into quickly a terminology. Okay, so what we're going to do is we're going to do a side-by-side comparison of some of the terminology. And again, idea here is to give you a flavor of Postgres usage and the terminology and the connectivity using how you do things today in Oracle, and get a quick starts for learning PostgreSQL. So let's start with some of the terminology. In Oracle, we call it instance, right? Memory plus background process. Postgres, we call it cluster. The reason we call it cluster is because it's multiple databases you can create inside Oracle. I mean, inside Postgres. Like Oracle now it's possible because of CDB, PDB, but I'm still comparing with the basic one. Uh, in Oracle, we have table and indexes. In Postgres, we call that relation. That doesn't mean you can't call it table and index, but that's the official terminology. Oracle, we call it row. In Postgres, we call it tuple. Column is called attribute. Now this is interesting. So in Oracle, we call it block, right? It could be 2K, 4K, 8K, depends on how it is. In Postgres, we call it block when it is in the disk, but when that block comes into memory, we call it page. But it's one on the same thing. Database, pretty much similar like what you would see in Oracle. Table space, again, you create database, you create table space. As I mentioned before, right, Postgres actually does not have a data file. The object you create directly, they go inside the table space. Postgres does have trigger, views, and sequence, but it does not have a synonym. So this is where it gets a little interesting. In Oracle, if you want to refer one schema or object of the one schema from other schema, right, you normally would create a synonyms, and then those objects you'll feel like they are local objects to that schema, right? Postgres does not have synonyms, but you could use search path using which you can directly jump from one schema to other schema. Postgres does have function, procedure, schemas. It also has users and roles, just like how we would have them in Oracle. The difference here is if you create a user with login, it becomes user. But let's say if you create user without login, that means you don't give a connect permission, it becomes a role. So these commands are kind of interchangeable. Okay, if you create a role with login, that becomes a user. This is just to give a flexibility there. But yeah, the idea is one is a role where you have a group of permission, and then you grant that permission to individual users. What exactly we do in Oracle. Okay, Postgres does have foreign key database link. So in Oracle, if you want to refer remote Oracle object or access that from one database to other database, we create Oracle database link. Okay. In Postgres, you can achieve similar functionality using FDW. So you can, from one Postgres database, you can access another Postgres database or Oracle database or SQL Server or even any ODBC data source using foreign data wrapper. Okay. Very similar functionality what we do in database link. Postgres does have a temp table space or temp table. It does have a type, so you can create your own user-defined data type for some of your complex needs. This is where it gets really interesting. So when I started learning Postgres in like 2011, and I coming from Oracle background, I was trying to understand how the undo table space works in Postgres, and then I realized that Postgres doesn't have undo table space. And then I started kind of deep diving, and it took a while to figure that out, how the concurrency would work if there's no undo table space. And I have a specific slide for that need. Postgres does have a materialized view. It does have a partition. So Postgres supports list, range, and hash partition to partition table. It does have a replication, just like Oracle has a data guard or golden gate for or logical replication and data guard for physical replication. Postgres have something similar feature, and I have our dedicated slides for that. Let me make sure that I see a couple of Q&A coming. So let me make sure. Okay, I'll probably answer those. So yeah, that's about a quick terminology comparison. Let's jump into terminology which are very, very specific to Postgres. And if you are learning a Postgres, or you have already started learning, these are the terminology which probably you want to focus on and understand. And these are like pretty deep. Each of them can take like, a few slides to understand, but I'm going to keep it at the very high level. As I mentioned before, Postgres does not have an undo table space, right? So what it does is it stores the record inside the same table. Okay, and we'll go through that side-by-side comparison in one of the slide. But if any record which is, so Postgres does not delete the record physically, but it marks that record delete, soft delete. It marks that as a soft delete. And that's the record called dead tuple. Okay. Now, when you perform any transaction in PostgreSQL, it assigns a transaction ID, and that's how it maintains the multi-version concurrency control. Now, this transaction ID is 32-bit, That means you can only do 4 billion transaction, and after that it's gonna wrap around. So that's once it reached to upper limit, that's called a transaction wraparound. And there are a few maintenance tasks you have to keep doing to make sure that you are not running into transaction wraparound scenarios. And I'm going to keep it at the very high level, but just to introduce you to some of the terminology for the PostgreSQL. Uh, One good thing about the PostgreSQL is it's an extensible database, means you can extend the database. You can write your own module, you can write your own code and plug that with the PostgreSQL. And then you do create extension, attach that code. Now that code will behave just like it's a part of the Postgres or existing Postgres. So this is one of the beautiful functionality I like about Postgres, where you can keep adding your features which are not supplied by community, or you can download external extension and attach to a PostgreSQL. If you remember, we spoke about dead tuple. So there is a process which cleans this dead tuple, and that entire process is called vacuum. Uh, in Oracle, let's say if you have a 4K or 8K page, and if record does not fit into that page, what happens is like you allocate a new page, and then the pointer occurs from like one page to other page. That's called Oracle row chaining, right? Postgres has something called a toast, the oversized attribute storage technique. So Postgres use that technique to store a record which are larger than the page size. In short, it creates the LOB schema, pgtoast schema, and that's where it stores remaining records. In Postgres, you do analyze, which is very similar to what you would do on DBMS gather state or collecting the statistics for schema or table or individual or entire database. Write ahead logging, which is very similar to redo log or transaction log, and MVCC, which we'll discuss in one of the slides in detail. Any questions so far? Please again, I want to remind, please feel free to use the Q&A. We'll take some of the questions at the end. So this is a quick comparison on a system catalog. So in Oracle, there are two main type of system catalog, $V and DB underscore, right? If I want to do a side-by-side comparison for some of the system catalog, this is where I would start with. If you want to see database properties, PG underscore database, which is very similar to what we would get into $V database. If you want to see what all sessions are currently under or connected to database and what's the status of that, what kind of wait events, you would use $V session. In Postgres, you would use PG state activity, and similar way you would use users, tables, roles, and a lot more. This is like pretty, a high level snippet of the comparison, but of course there are like a lot many system catalog tables. One of the interesting one is $V parameter and PG settings. This is where you'll be able to find what all different parameters are configured or for this particular database or instance. Okay, so let's move into the next one. So we compared logical architecture, physical architecture, again at the high level, some of the terminology, some of the statistics on some of the metadata, right? Let's see if I want to install PostgreSQL, how I would do that. So if I need, let's start with how we normally would install Oracle, right? We would mount the disk or download that, a software and then unzip it and do all that good stuff and then run uninstall, right? This is what I would do on Oracle. Again, remember, if I have anything on red color, that's related to Oracle command. If anything is in a blue color, that's more related to Postgres commands, just for, just to differentiate. If you want to install PostgreSQL on Unix box, okay, all you would do is you'll create a repository, okay, you'll update the package list and just install the PostgreSQL, and that would install the PostgreSQL. Like in this case, I'm installing the latest PostgreSQL, which is 15 version, using sudo apt-get. If it would have been, let's say, Red Hat Linux or something else, I would use sudo yum install. But if I issue this command, it's gonna install latest PostgreSQL, which is a 15. If I have a need of installing any other version of Postgres, let's say 12, 13, 14, then I would give -12, -13, or -14, and it would install that particular version of Postgres. So once the Postgres is installed, the next one is, how to create cluster, how to create database, right? That's something similar we would do on Oracle also, right? Once the binary is installed, the very first thing we would do is we'll create a init.ora in Oracle case, right? uh, you know, Startup no mount, which will bring the instance, right? Then we'll create the database, mount the database, and now the database is ready to use, right? Of course, we'll do a lot of other configuration like listener.ora and then set up a remote connectivity and all that. But just to start with the comparing, right? So similar way, if the Postgres is installed, the very first thing you would do is you'll create a cluster, and also you will give a directory or data directory. So initdb what it would do is it will create the cluster and it will also create the default database. Once that is done, in Oracle, if you want to compare start and stop command, which is like startup and shutdown, Postgres, you will use start and stop. The difference is here you'll give the data directory name, like just to identify which cluster you want to act upon, right? That's where you will give this information. And then if you want to restart, which you want to combine, let's stop and start both command. Postgres is a command of restarting. So all these commands again at the cluster layer where you're creating a cluster, you're starting cluster, you're stopping the cluster, you are restarting the cluster. One more thing, if I want to compare with PostgreSQL, in in Oracle, if you want to shut down database, right, there are three different options we use: shut immediate, shut abort, and shut down. Right? Shutdown is more like graceful shutdown. And then shut immediate is gonna, get rid of all existing connection. Again, it's gonna do a checkpoint and kind of, one level below graceful. And shut abort, it's like kill line. It's just gonna shut, no, it's not gonna perform any checkpoint, but just gonna shut down the process. Postgres has something pretty similar. When you shut down, you can define one of the mode here: smart, fast, or immediate. Fast is a default one, which is equivalent to shutdown immediate. Smart is like shutdown, where it's going to wait for all of the process to get exit and then only going to perform shutdown. Immediate is just like a shutterbot. Okay. So that's a quick comparison between how you would create database, how you will stop, start, and restart database. I'm quickly checking if there are any specific questions. Okay, so far what we did is we downloaded binary, we created a cluster, we installed PostgreSQL. Once you install PostgreSQL, and if you try to grab for all the Postgres process, this is how it would look at the initial. You remember we created a PostgreSQL on data 01 directly. This is where it's going to show you, this is what your data directory is. This is what your PostgreSQL conf file, which is very similar to init.ora file. Okay, if you want to compare side by side. And these are all your background process. Okay. So it starts with the Postgres process, which is your, a postmaster process. That's what we used to call it. And then these are all the background process. So this is like a default. This is your entire cluster. Okay. Background process plus the memory allocation. So since now we have installed Postgres, let's see how do I connect to PostgreSQL, right? So what you would do is, if this would have been Oracle database, normally we would sudo switch you as an Oracle user and then connect as a sysdba, right? That's how we would get inside Oracle if Oracle is installed locally on the Unix box. Similar way on Postgres, you will do sudo switch you Postgres and then just do psql, and then you are inside PostgreSQL as a sysdb or super user. We call it super user, not just to compare with sys user. Um, if if you want to restrict that, okay, nobody should be able to do, direct login and must use a password. You remember there is a file called PGHBA, host-based access authentication. That's where you can provide a lot more additional configuration. So anybody who log into the database must have to supply password. This is if the Postgres is installed locally, just like if Oracle would have. Now, we also sometimes connect Oracle from local desk or local client to remote database, right? And we use tnsnames.ora or we use entire string for connecting. You can do something similar using this method. Okay, so you do psql, remote host name, remote user, database name, and port. If you see in Oracle, the default port is 1521, while in Postgres, the default port is 5432, just for a comparison purpose. Okay. You can always use a higher version of client to connect to a lower version of server and vice versa. So it's all backward compatible. Okay. So this is again, if you want to come, just to summarize, if you want to connect locally, this is how you would do it. If you want to connect from remote as coming as a client, this is how you would do it. So one of the tool, and it's just not limited to SQL developer, but lot many other tools, GUI tools are available, which you use for exploring or looking at the database metadata, right? Postgres has something called pgadmin for. This is again a free tool. It is again, if you go to postgresql.org, you'll find this, how to download and what are the steps. But this is a tool you will use for connect. Because some people like to use GUI version of connecting and exploring, what are the objects, data types, extracting DDLs and so and so. So pgadmin is a tool or it's a good starting tool for you, just to understand how things works. The beauty about this tool is it also gives you information about, what are the sessions are running, how many transactions are happening per second, provided you have, those access to look at those metadata. And also you have, options to look at like various object types by browsing them. Okay. So yeah, that's about quick time check. That's about, connecting to PostgreSQL. Now, so we install PostgreSQL, we create a database or cluster, and we connected using GUI, right? Let's see what is inside PostgreSQL, okay, cluster. So when I connect very first time from GUI or let's say from command line, what do I see inside, okay? So Postgres is a very short command like \l, \dt, dx, which gives you behind the scene. It of course runs a various command, but it's easy way to figure out, how many database do I have it, how many tables do I have it, schemas and whatnot. So if you create a plain cluster, plain Postgres cluster, you would see three different databases: Postgres, template 0, and template 1. Okay. So Postgres is a default database where you'll connect. Okay. Because when you're connecting to cluster, you have to still connect to a database. You can't just connect to a cluster. So this is a database normally. If you're not specified, this is a default database you'll connect. Okay. Then there is a template 1 and template 0. So these are the default template for creating a new database. And this might probably remind you what we would see in a PDB, CDB or seed database, right? Or pluggable database. So if I create database data whale, behind the scene, the data whale database is gonna be a copy of template 1, okay? There are also a lot many options you can define, encoding, collation, and how many users you want to allow, how many number of connections you want to allow, and a lot more other thing you can give. Also, you can give one of the existing database as a template as well. So if you don't give it by default, it's gonna take a template 1 as a default database. So yeah, again, the key difference is Oracle, one instance is one database. In Postgres, one cluster is many database. You can create as many as. Okay. Any other questions so far? Okay. So let's jump into MVCC. If you remember in our quick comparison, we did not see an undo table space, right, in PostgreSQL. So let's try to understand, and this is the topic I wanted to a little bit deep dive and see how Postgres would achieve the same functionality what Oracle would achieve through undo table space, right? So in case of Oracle, if you perform an update, okay, what happens is like current version of row gets updated in place, right? So in case of, let's say for employee 100, if you are changing the salary from, let's say 100 to 110, okay, the salary equal to 110 gets updated into an existing row, and the old image goes into undo table space, right? And that's the image used for rebuilding the previous version of block in case if user decides to do rollback, or if you have an old report or old session which needs the previous data for consistency purpose, right? That's where the undo tables comes into picture, right? And once, let's say, the transaction gets committed and all the older data or older report gets committed, or they're no more into a picture, that's where undo table space is gonna get erased. Depends on what's your undo retention. And let's say if your undo retention expires and the older report still needs those record, you're probably gonna get a snapshot too old error, right? That's one of the famous error you probably all of us would have gone through, right? Now, how does Postgres achieves that? So what Postgres does is it creates copy on write. That means let's take the same scenario for employee 100. We are changing the salary from 100 to 110. Okay. What it does is it creates a two copy of that. Okay. So one is existing row and the other one is a newer record. Okay. So at one point, you're gonna have two rows sitting in the same table. Okay. And again, I have one slide right after this to give a little more demonstration on how that happens. Okay. So updated row is copied to a new version. That means you have two records sitting in the same table. Okay. All your index are now going to point to a new record or new address. Okay. The benefit you get because of this is your commit or rollback is pretty fast because you don't have to really go and take care of your undo table space, remove that space, or update address and all that, right? And so your rollback also, if user decides to roll back, all you are doing is pointing back to the previous image in the same table, right? But the downside of this is now you have a dead tuple or you have a garbage record. Let's say user commits that, change the salary from 100 to 110 and commits it. Now the older record is dead tuple. It's not being used by anybody. And, and now this record becomes a dead tuple. This is where the vacuum process comes into picture. So vacuum process comes, it figures out, it has algorithm that, okay, which all records are dead tuple, and it's going to start cleaning those. So those records are, or those space is used for a future usage. Okay. So I hope this gives kind of, a high level idea on how undo table space would work. Let's go through quick examples. Okay. And, we have another 20 minutes left. So let's take a quick example. I've created a test table. Okay. It has a two columns, ID and name. Okay. And if you remember in one of the slide, I mentioned that each transaction has a transaction ID. Okay. So let's say when I'm performing this insert, and for this particular insert, the assigned transaction is 735. Okay. So just remember this transaction number, and we'll go through where it comes into a picture. If you describe this table, you will see like two IDs. Okay. And I've inserted, let's say, two records. I mean, the one record, 100 and Bob, right? ID is 100 and the name is Bob. If I do select star from test table, 100 Bob. Yeah, pretty similar what I would see in Oracle, right? Now, Postgres has few hidden columns. Okay, if you remember, if we just did select star from table, all we saw is like two columns, nothing more than that. But Postgres has many hidden columns called transaction mean, transaction max, C means C max, and city ID. City ID is something like your address of the row. I would say it's more like a row ID on Oracle or row num. Yeah, I think it's a row ID more. So I inserted this transaction at the transaction 735. Okay, the transaction number 735, and this is again internally managed by Postgres. Okay, so any transactions, and this is constantly moving number. Okay, so 735, 736, and so on. So any transaction which are equal or higher than 735, they will all be able to see these records. Okay, any transactions which are started before 735, they will not be able to see this record. Okay. Now we wait for, let's say, a couple of minutes and then perform update on this record. Okay. I change a name from Bob to John. Okay. At transaction 748. Okay. And now if I go and check my xmin, okay, my xmin would have got updated to 748. Now, let's say if I have not given commit here, At that point, I will have a two records sitting in the same table, one for 735 and one for 748. So any transactions which are in between 735 and 748, they would see this record. Any transactions, and let's say if I give a commit, any transaction after 748 transaction ID, they would see this record. And let's say if we don't have any previous transaction or long running report which needs these transactions or this particular row, in that case, that vacuum process will come and clean up this data. And so first of all, Postgres will mark this as a dead tuple because it knows that nobody's using now. All the old running reports are done, plus the transaction got committed. That means it's going to mark this flag as a dead tuple. Now, once it's marked as a dead tuple, the vacuum process is going to come and clean this record. There are a lot of parameters related to vacuum. How quickly you want to clean this, how frequently you want to clean it, what should be the aggression rate, and so and so. Okay, so I hope that gives a little bit idea of how undo equivalent functionality works in a Postgres. Again, I really didn't wanted to like deep dive, but wanted to explain at the same time, by giving like one of the quick example. Okay, so again, quick time check. I know we have another probably 15 minutes left. Backup and restore. So in case of Oracle, two type of backup, right? Logical backup and physical backup. Logical backup is EXPDP, IMPDP. You can do at the entire database level, specific table level, schema level, and then you go and restore them using IMPDP, right? Or data pump. And then for a physical, there is a recovery manager or RMAN. That's what you use for taking a full backup and incremental backup. And if you want to do point in time recovery, this is what you will use. In Postgres, pretty similar option. PG dump, PG restore. You can take a entire database backup, set of tables, schema. That's what you'll use for logical backup. Um, this PG dump and PG restore, you can do a cross version restore also. Like this is just a CSV file, uh, and of course it also has option of uh, taking a backup into tar format and compress format. But you could also restore data from one version to other version. Postgres has a PG-based backup, which is just like a physical backup. So you will take a physical backup. And if you remember, there is an archive log process, which keeps generating archive log. So combination of PG-based backup and archive log you will use for point-in-time recovery or end of the logs or whatever you pretty much would do with RMAN. Postgres also has a tools called PG Backrest, Barman, and Valji. So these are the tools integrated on top of PG-based backup to make it, introduce like a lot more features like encryption or taking a delta backup or cumulative backups or so and so. These tools are also integrated now with, Amazon S3 bucket. If you want to like offsite your backup directly, you want to stream your bucket, backup to Azure Blob Storage or so. These are the tools which helps you in doing that. Okay. So yeah, that's about quick comparison between backup and restore in Oracle and PostgreSQL. Let's jump into a last set of our segment, which is a high availability, right? So in case of Oracle, pretty famous thing, right? A rack cluster where you have multiple nodes sharing the same storage, and then Postgres does not have pretty similar to what rack would do, okay? But it does have a streaming replication, which you can compare with a data guard. It does have a logical replication. If any of you coming from a SQL Server background, you can create a publication, you can assign like various tables to that publication, and then anybody could subscribe those tables and get a copy of insert, update, delete, and the main table, right? So that's whatever functionality you would achieve through Golden Gate, something similar you can achieve through logical replication. Okay, for entire database, for set of schema, for set of tables or so. And Postgres also has a Patroni cluster where you can do a streaming replication with little bit of automation. Okay, and let's go through some of the examples there. So streaming replication, you have your master database or primary database. It streams the log file or redo log file or WAL in terms of Postgres terminology. The WAL record gets shipped to a different data center. Of course, you would have first restore entire physical copy of this guy, this master database, and then you would have started streaming those logs. This is very equivalent to a data guard. Like in data guard, we also have a tool called DGMGR, right? To like control the data guard and set up data guard. Similar way, Postgres has a replication manager. If you don't want to do anything manually, using replication manager, you can, quickly set up the streaming replication. Postgres does support a delayed replication. So let's say if this is your data center one, you want to have a 30-minute delayed replication to data center two. So if somebody makes any kind of accidental mistakes like dropping the table or deleting record, you have 30 minutes to go and recover here. So it does support delayed replication as well. The second option is logical replication, which is equivalent to a golden gate, right? Or a streaming replication, or where you can replicate. In case of golden gate, you can replicate set of data or set of tables from one data center to other data center or one server to other server, right? And they're both going to be active node, of course. In Postgres, you can do something similar. You have two active node. You create a publication here, assign set of schema or assign set of tables here. You create a subscription here. And now whatever changes you do on those tables or schema, they will get replicated into your data center 2 or server 2. This is more if you want to have an object level replication. It could be at the schema or it could be at the tables level, set of tables. This is the last one, which I would probably compare this with the data guard with auto failover. So there is a tool called Patroni cluster. Okay, this again comes as an open source. What you would do is you're gonna have one master node and multiple slave node. You're gonna have a HA proxy sitting on top of it. So application is always gonna talk to HA proxy, and HA proxy knows which guy is a primary out of these three. Okay, and also you're gonna have etcd running on either the same node or different node, which keeps track of heartbeat of or health of all of these, and also keep track of entire metadata of this cluster, right? Let's say because of some reason, if this node goes down, or if we need to take this under maintenance, the HA proxy would automatically know. First of all, etcd will automatically know that this node is going on maintenance or it crashed. It's gonna go for election process and gonna set one of the slave node as a master node. Okay. And also gonna update the metadata. Now HA proxy knows based on one of the flag that one of these guy is master node and gonna start sending traffic automatically without application making any changes. And once this guy is back, this can be marked as a slave node. And again, etcd will get updated with the metadata and this will start behaving as a slave node. Okay, so this you can compare with like data guard with auto failover. I mean, that's the closest terminology I could think of. But yeah, I think that's pretty much about all the high availability option. Of course, there are a lot many, but I wanted to show like some of the key one here. So that concludes the session here. Again, please, if you're not filled this survey, I request each of you to please fill out this survey. And I think that's all I have it. We have about 10 more minutes left if anybody has any specific questions. Okay, so I'm getting a couple of questions here. Is data 01 like a mounted files? Okay, so the data 01, and let me go back to that slide quickly. So this is your a file system, or it could be a data directory within file system. Okay, you can have a multiple cluster running on the same server. So you could create another folder called data02. Okay, of course you have to start that with a different port because you cannot have two port running on the same server, right? So that's more like a different folder, different different directory for that given cluster. I don't know if that helps in answering. Okay. So that's, yeah, it's just like a, I mean, you could compare that with the mounted file, but I would still give a more comparison with, like, um, it's just a folder, and that's where all your Postgres data resides, all your metadata, all your cluster configuration, and all that for that given cluster. Like, if I want to create another cluster with a different port, I will do pgctl initdb -d data 02 or whatever name I want to give it, right? So that's how it would be. I'm getting another question called, what tools we can use to migrate database from Oracle DB to any other source, Oracle DB or any other source to PostgreSQL. Okay. So if I speak about Oracle to Postgres migration, there are various tools. Okay. Ora to PG is one of the famous tool. You can write, um, so Ora to PG. Okay. And let me type. And also, if you are using, if you are planning to migrate to, let's say, cloud platforms like AWS or GCP, they have their own tools. Like AWS has something called DMS, Database Migration Services, which does a full load, and also it does the incremental load. So your Oracle and Postgres always gonna be in sync. Okay, and Google has something similar as well. If you want to planning to migrate from, let's say on-prem Oracle to AlloyDB PostgreSQL. Okay, so yeah, Aura to PG, or AWS DMS, and yeah, there are many tools like that. Yeah. The other question I'm getting here is there a multi-tenancy option like Oracle for PostgreSQL, like multiple database for one cluster? Okay. And this is not rack equivalent, Samuel. So when you create database in PostgreSQL, okay, if I go back to this example, right, you can have a multiple database sitting on the same cluster. So I could have, you see a database called data whale. I can create, a database 2, database 3, database 4, and they all are independent database sitting inside the same cluster. Okay. The closest comparison I want to give is like a PDB CDB, where you could have like so many pluggable database sitting inside the same Oracle instance, right? I think that's probably the closest one I can compare with. But I have not seen rack equivalent option in Postgres. I wish there is one, but at this point I haven't seen one. Yeah. Yes, we're gonna get a slide. So you would see a slide. This slide will be sent across by organization team. So you would see those slides. Any other question? Let's go down quickly. Okay. There's a question that I did not see package or package body translation. So yes, Postgres does not have a package or package body, unlike Oracle. But you have a store procedure, functions, triggers. So you probably have to, so if you have a package, you have to like segregate them individually object if you are migrating from Oracle to Postgres. Another question I'm getting is like, does Postgres have a remote connection like listener and TNS names? So it does not. All you have to do is, if Postgres is running on the remote box, and if you are allowed to connect, let's say there is a file called pghpa, okay? If pghpa has authority, so let me give quick examples of pghpa. Okay, so yeah, you see a file called pghba here, right? So let's say I have a Postgres installed on server 001, okay? And I'm connecting to Postgres from 002. That's where my Postgres client is installed. If pghba allows connection from server 002, which is my client, then I can, and provided I have a, credential and password and username, then I can connect directly from remote server or remote location to that particular database. Okay, but it does not have something like listener dot Ora, or so. You just go, you just install the Postgres and just start connecting there as a remotely. I think we have another 1 more minute to take a question. So how does tech support work since it's an open source database? So pretty interesting question. In case of Oracle today, right? If anything happens, we create Oracle SR and somebody from product team comes into picture and helps, right? But in case of Oracle, um, you know, that's where the companies like Data Whale, who has experts on Oracle, plus there's a community. If you find any bug, okay, you go to communitypostgres.org, open a ticket, and most of the time I have seen pretty quick response on that. Okay, either somebody comes with a workaround or somebody comes with, takes that as a patch. Now they do not provide a patch, so most of the time the patch comes, but that patch is gonna come as a part of your release, a quarterly release or monthly release. But most of the time you're gonna end up getting some workaround there. Uh, how does the licensing cost work compared to Oracle? Pretty good question. So there's no licensing cost. Okay, if you are using a community PostgreSQL, you just download it and you start using it. Okay, it's a completely open source. Okay, I think we are right on the dot. So I'm gonna um, you know pause this right here. And if there are any additional question, we can certainly talk offline. Again, thank you very much for your time. Was nice answering all of these questions. I hope you all thoroughly enjoy it, and I hope you enjoy rest of the time here at RMUG 2023. Thank you again. Have a good rest of the day.